Hello students, welcome to the Sarat Chandra Academy, and today we are going to discuss JEE-1 2026 paper 1 physics. Okay, so paper was moreover you can say conceptual based, and you can say little bit lengthier to solve, but it was doable. Okay, there were many questions which were doable, especially match the columns. Okay, they were very easy to do. So let's see one by one. So first we start with, so first we have single correct. So paper pattern was somewhat predicting only, like single correct, multiple correct, then numericals, and then after your match the column. That is not a problem. Now let's start with the first question. So what is question is saying? So this question is based on like little bit rotational dynamics. Consider a large disk of radius capital R and two smaller disks, each of radius small r equal to r by 50. Okay, so these are smaller disks which have radius r by 50. Lying on its circumference as shown in the figure, smaller disks are initially in contact with each other with angular separation delta theta. So their centers have an angular separation delta theta. Okay, they are made to roll without slipping in opposite direction. Remember, without slipping, okay, delta theta with constant angular velocity omega and 2 omega. While the large disk is held stationary. So this is stationary, very good thing. The time tau at which the smaller disks are again in contact. So this will roll and come this side, and this will roll and come this side, and somewhere they will meet. How much time it took, that he is asking. Okay, sine delta theta equal to delta theta, that means he is saying delta theta is a small angle. Okay, so you have to consider delta theta as a small angle. Now how to start this question? Now try to understand. We will if we go according to rotation like this, rotate, okay, it will be little bit difficult to solve. Okay, so what we have studied in circular motion, that part we will use. Okay, omega relative, if we get that this center will go from this, you keep stationary, and this you move relatively, and this you bring here, right? So actually what is happening is, if we find out somehow that this disk roll and come back here, right? Instead of disk also, we just move the center to center. Okay, so this center is moving in capital R plus small r radius, and this center move and come back here, right? Because this disk will come here, center will come here, so this will move this much, right? So this will be again delta theta. Okay, so it have to move 2 pi minus 2 delta theta. Okay, and that will be our final answer. How much time it took relative to this point? This point is moving starting from here and coming back here. Okay, just we have to bring in the minimum number of variables. Okay, because too much elimination is happening here. Capital R, small r, nothing is there, right? So let's start. First of all, if you will see from center to center, this gap is what? 2 into small r, correct na? So if I want to write down delta theta, how much that will be? Delta theta, I can say angle, right? So that will be your arc length. Okay, 2r divided by, in what radius it is? Capital R plus small r. Agree? Yes, na? Then after, if you see, if it is no slipping, without slipping then this point is stationary, that means this point is going with r omega, correct? So let's say this is going this side with certain v1. Let me mark. This is going this side with certain v1, and this one will go this side with v2. Okay, what are those v1, v2? Let's understand. So v1 will be what? I can say small r into 2 omega, right? So that's a 2r omega, and v2 will be small r into omega, that's an r omega, correct? Okay, why I did that? Because I am finding out that center will rotate here, right? So with what angular velocity? If I answer omega 1, okay, omega 1 is what? With which the center is rotating in this bigger circle, right? Capital R plus small r. So I know the speed of the particle, right? And I know what radius it is revolving, capital R plus small r, right? So what will be the angular velocity? You know v equals to r omega, right? So omega will be v by r, correct? So v is what? v1 by r is what? Capital R plus small r. So v1 is what? 2r omega divided by capital R plus small r. Similarly, omega 2 is what? R omega divided by capital R plus small r. So here this center is going this way with omega 1 speed, and this center is going this way with omega 2 speed. Okay, that's what I solved till now. Okay, now what will happen is that this I will using proper circular motion. Okay, that this particle is coming this side and hitting it this side, right? But particle is coming till what angle? Here you can say this is delta theta, this is delta theta. I have to bring this keep stationary, This bring from here to here only, right? So that's a 2 pi minus 2 delta theta, correct? That much angle only is traveling. With what angular velocity? With angular velocity omega relative. What is omega relative? Because both particles are traveling in opposite direction, so omega relative will be omega 1 plus omega 2. Agree? So omega 1 plus omega 2 is how much? 3r omega. 3r omega divided by small r plus capital R. Okay, this much you got. Now we have to solve for time. Okay, so for time we can say that how much angle it rotated, that will be 2 pi minus 2 delta theta divided by, with what angular velocity? Omega relative, that will be 3r omega. So just a second, the problem will be there that we have to put this value. So what is the value of small r divided by r plus capital R? That's a delta theta, right? So this will be 3 delta theta omega by 2. Okay, and if we calculate delta theta also, we can answer delta theta how much. So small r value is capital R by 50, right? If you put here, this will be 2 into capital R by 50 divided by capital R plus capital R by 50. So that's a 51, 50 cancel out. So that will be 2 by 51. 2 by 51. If we put the delta theta value here also, then 2 cancel out, 3 omega by 51. Okay, so here put that value. So here delta theta value also let's put. Okay, let me write down one more step. Omega relative. Okay, next page we can write down. Time is equals to 2 pi minus 2 into delta theta. Delta theta is how much? 2 by 51. Okay, 2 by 51 divided by, how much is that? Here omega relative is how much? 3 omega by 51. Okay, 3 omega by 51. Okay, so from here any option we have 51 common he is keeping and 3 omega and denominator. Okay, so somewhat we don't have to cancel out. If we keep 51 here and then 2 pi minus 4 by 51 divided by 3 omega, something like this option will be there. 4 by 51. 4 by 51, 4 by 51 is there, 51, 3 omega, C option. Okay, so C option is our correct answer. Okay, I hope this is clear. Next you see. Next question, consider a circuit consisting of a capacitor of capacitance C and a coil with n turns per unit length. Okay, so n turns per unit length. N turns per unit length is there, cross section area S and length D. Okay, for the bigger coil, how much is given? Capital N turns, cross section area S and length is D. Where D square is very large comparison to S, for that meaning is we have to consider it as ideal solenoid. Okay, there is another coil of length D by 2. So inside that there is another coil of length how much? D by 2, cross section area S by 2 and number of turns double, right? And per unit length, remember, completely inside the larger coil as shown in the figure. The ends of this smaller coil are connected with each other by an insulated conducting wire. So this we connected with an insulated conducting wire, right? The self-inductance of the larger coil is capital L. So for the larger coil, self-inductance is capital N. That capital N terms only is writing some answer. What is that? Resonant frequency of circuit. So we know resonant frequency of the circuit is what? 1 by under root L effective into C. There is a inductor and there is a capacitor. So LC oscillation will be there, right? For that. Okay. Now see how we'll solve. So first of all, what is this capital L? So first of all, capital L is what? Mu naught, okay, N square into is area of cross section S and D. So S into D. This is the L, right? So in this you consider I1 current and in this one you consider as I2 current. Okay. So first of all, I1 is there, correct now? So L2 will be what? L2 will be mu naught into 2N square into S area is what? S by 2 given, right? S by 2 and D is also given D by 2, right? So this will, if you see 4 factor cancel out, so L2 is nothing but L, right? Now solve one more quantity which is mutual inductance, right? How you will solve for mutual inductance? Calculate the flux through the smaller coil and flow the current through bigger coil. So for the bigger coil, if you flow the current, what will become? Mu naught capital N into I1, because it have N capital N turns, right? So this is the magnetic field. Now for the flux, we know 2n turns per unit length into length is d by 2, right, into area of cross section s by 2, right? So s by 2, 2 factor cancel out, 1 2 remaining. I1 will come outside, then mutual inductance will come, and that will be just divided by 2 factor is there, means it is L by 2. Okay, so mutual inductance of these two coils is what? Self inductance by 2. Okay, half of the self inductance. Now what we have to do here is that for the smaller coil, if you see, for a smaller coil, right? So what can I say for the smaller coil? For the smaller coil, I can say flux, either you can write down or directly EMF write down. So L into this current is what? I2, right? I2. So dI2 by dt, okay, minus L by 2 dI1 by L by 2 mutual inductance by dt is equals to 0, right? Because you don't have an EMF, right? So that will be equated to 0, okay? And for the bigger one, bigger coil, for that what you will write down is, for that only you have to calculate the L effective, right? So what you will say is that here you will say I1 current is there, right? So L into dI1 by dt, okay, that's his own, by his own current, and by the mutual inductance you will have minus L by 2 into dI2 by dt, and this will be equal to L effective, if you want to write down in terms of I1 only, right? So L effective into dI1 by dt, right? From here we can solve for L effective, right? So what you will do is dI2 by dt is there, so dI2 by dt, if I see, that will be half of dI1 by dt. So here you will put half of dI1 by dt. So dI1 by dt into L common. Here you will have 1, and here 1 by 2 into, from here 1 by 2 factor will come, that's a 1 by 4, equals to L effective into dI1 by dt. Okay, so from here if we compare, the L effective is how much? 1 minus 1 by 4, that's a 3 by 4, so 3L by 4. Okay, so your resonant frequency is 1 upon under root 3L by 4 into C. So that's a 2 will go in numerator under root 3LC. Okay, that's your final answer. So do we have anything like this? 2 by root 3LC, that's the C option. Okay, so I hope this will be clear. Got it? The main part was this, to calculate the L effective. That is only the part to be solved. Next question. Okay, if we see here, consider what is the question given? A solid cylinder of radius capital R rolls without slipping. So this is also capital R radius without slipping. Okay, center of mass with the speed V0. V0 is given. Okay, on a horizontal surface with a vertical edge as shown in the figure, right? So he's not saying it is moving, so keep it stationary only. Horizontal surface with a vertical edge. Okay, this is vertical edge. Here G is the acceleration due to gravity. Okay, at the moment when the cylinder loses contact with the surface due to rotation around the corner, the speed of its center of mass is, okay. Obviously 0 is not the answer, right? So what is happening here is that I will draw it little bit bigger. Okay, so this is R, obviously R is given, right? Radius R given. So this is capital R. I am drawing it little bit bigger here. So what will happen is this will come here and it will lose here contact. It's like, let's say, falling from here and like this it will fall, right? So at the time he will lose the contact. At that time he will be little bit down, right? And he will be going down like this. So at a certain angle he will go. At that point he's asking the center of mass velocity, right? Speed of center of mass. Okay. So how you will solve is, you consider that it came here at this point. Okay. So it is not directly up, here is this side. So center is here somewhere. Okay. So let's say he rotated how much angle? Theta here. And currently he is going this way with the V speed. Okay. Fine. Now what? Now first of all you write down the energy. I think by energy it will come, right? So if you write down the energy, what you will say? Kinetic energy. We know kinetic energy will be what? Okay, the translational plus rotational, right? So translational is half mv0 square. Okay, plus no slipping is going on, so half I omega square, and moment of inertia of this is what? Solid cylinder. So you can collapse like this, mr square by 2, mr square by 2, simple, right? So here rotational kinetic energy will come what? Mr half I omega square. So R omega is V, right now, because without no slipping condition. So that will give you the half, let me write down, Mr square by 2 into omega square, half I omega square, right? So R into omega ka whole square, that's a V. So this is 1 by 4, this is 1 by 2. So that's a 3 by 4 mv naught square. Agree? Yes. Okay. So that's the initial kinetic energy. Okay. Now final, if we see, then finally what has happened is I drawn it a little bit bigger. Okay. So this is R. Okay, here R, and this is now what? R cos theta, correct na? If you see the vertical, this is R, right? So this is R, then this is what? R cos theta. So from the R, it came to R cos theta, vertically height. So it vertically, the center of mass displaced down. If you see here, let me draw here. It is, the edge is like this, here, okay? The edge is somewhere here like this, correct? Okay, so here is the center. This is radius. If you see here, earlier the center is at R radius, correct na? Here somewhere, here above. And now it is vertically from this surface, if you will see, he is R cos theta above. If we consider this angle as theta. So he is just R cos theta above. So from R it came R cos theta, means it came down. Down came means potential energy decrease. Potential energy decrease means kinetic energy increase, right? So if you write down here, this is kinetic energy, and write down the potential energy also. Initial potential energy, consider ground this as a reference, right? So you can say just mgr. Okay, I don't want to confuse, that's why I am writing initial potential. I can write down the total energy also, initial, final, but that will confuse you. So let's write down final. So consider the center of mass is going with v speed. Okay, v speed, right? So here if I write down the kinetic energy final, right, so that will be similarly half mv square, right? But now you write down about this last point, he is revolving, right, like this going, correct, omega, okay, at this point of time. So similarly it will come about this point, right down, correct? You will have still valid v equals to r omega. Okay, I hope I have not used the omega thing here. I have used here, so keep it omega naught. Okay, that's it. Other than that, no used. Okay, so here v equals to r omega. Okay, so about this point it is rotating. So if you write down kinetic energy, you can write down in terms of directly from ICR point, correct? This is ICR point, so I can say half ICR is what? Mr square by 2 plus md square, right? So that is mr square, correct? R distance R. So this will be 3 by 2 again. 3 by 2 mr square into omega square, right? V equals to r omega, we can put, okay, V not there given, but we will write down later on. Potential energy finally, if you write down from this reference, right? So this is R, so this will be R cos theta. So you can say potential energy is what? mg R into cos theta. Okay, so from here, just do the energy conservation, that's it. Okay. If you want, you can write down V equals to R omega. By that you can write down the V only, because at the end our goal is to find out the V, correct? Yes. So we can also say this is 3 by 4 m v square, right? So if you write down kinetic energy initial, okay, that will be what? Here 3 by 4 m v naught square. 3 by 4, this I am writing kinetic energy initial plus potential energy is equals to kinetic energy final plus potential energy final. So kinetic energy initial is 3 by 4 m v naught square plus potential energy initial is what? mgr is equals to kinetic energy final is what? 3 by 4 mv square plus potential energy final is what? mgr cos theta. Now see, now the problem is V is also variable and theta is also variable, right? So how to solve for that? For that he gave us one more information here, that if you see here, at the moment when the cylinder loses the contact, at that point we have to find out. So when it loses the contact, see, here what will happen is that there is a normal force towards the center, okay, this way. Towards the center there will be a normal, okay, and downward there is a acting mg. These are the two forces acting, okay. So if you see, this is the center about which this is rotating, correct? So at the any point, if generally you will write down, right? So this will be theta, so this is theta, so this will come mg cos theta. So you can say mg cos theta minus normal. This will provide the centripetal force mv square by rotating in r radius, correct? But the problem here is that he's just losing the contact. Just losing the contact means this point he is still rotating, but at this point only the normal got 0. So normal is 0, right? So here what we have, mg cos theta. If we get the r this side, right, we have mv square, right? Now we can use this value, right? So put the value here. So we have 3 by 4 v0 also we are given. So let's use the v0 now. Gr by 3 under root, right? So square is there. So 3 by 4 m gr by 3. Okay. So we have gr by 3, okay, plus mgr equal to 3 by 4. mv square is how much? mgr cos theta plus mgr cos theta, right? If you see here, so mgr cancel out from everywhere, right? And 3 cancel out, this will be 1 by 4, right? Plus 1 is equals to here 3 by 4 cos theta and here cos theta. So that will be added 7 by 4. 7 by 4 cos theta, right? So cos theta is how much? Here 5 by 4, so 5 by 7, right? So that's a 5 by 7, okay? But cos theta is not the thing he asked for the v, right? So from here, if you put the value again, we can say v is equals to cancel out gr cos theta. So under root of gr cos theta, that's a 5 by 7, right? So 5 by 7 factor, 5 by 7, just B option, okay? So just what we applied here is the energy conservation, okay, because he moved down. And second thing we applied is about the center, okay? Net centripetal force equals to mv square by r, okay? Those two things we applied and we got the answer. Next, okay? This question, sometimes we can think it's a contradictory or something, but actually what the problem is that 1 by focal length is equals to mu, which is given here. So what is given? Let me read for you. A double convex lens made of two glass of refractive index 1.5 and radii of curvature of the curved surface is 20 cm each is immersed in a liquid of refractive index NL. The correct plot showing the variation of the power in units of diopter. Okay. So 1 by f is equals to refractive index 1.5 divided by mu of lens, right? Minus 1 into 2 by r will come. You can solve here, okay? R is, he asked in diopter, so we have to solve in meter, right? So this will be 1 by 5, 10 will come. Here if you take LCM, mu L, if you send this side, so mu L by F is equals to, this is 10, right? So keep it 10 into 1.5 minus mu L, right? Now this mu L by F is the power, okay? This was the only thing. Sometimes generally we keep the 1 by F as the power, right? Here mu L by F will be the power because he is inside the liquid, okay? Immersed in the liquid, correct? That's why. So power is defined like this. So here what will come? Maybe contradiction is there. So wait for it. Wait for official answers. So 15 minus 10 into mu L is on the x-axis. So that's mu L. So this is something like y is equals to 15 minus 10x, okay? Straight line. And if you will put for 1.5, x is 1.5, this will come 0, okay? So B option is okay. But if you consider that 1 by f is there, then A option will match, okay? So that, let's see for the official answers, but for time being B option we can keep. Got it? C and D there is no chance. Let's see. Next we have, so next we have the another section, multiple correct, okay? Let's see. So what we have is, consider a hydrogen atom. So this kind of questions we have already seen multiple times in JEE Advanced also, okay? And sometimes JEE Main also gives this kind of question. But what we have to do is, if you will see generally in JEE Advanced question, this kind of questions is multiple ways. We have to solve in a different manner, and we have to bring it in the what format is given in the option, okay? So let's see what are the tricks we have used to solve this and how we did it. Consider hydrogen atom with Vk, Rk and Kk denoting the velocity, orbital radius and kinetic energy of the electron in kth orbit respectively. The electron undergoes a transition from nth orbit emitting a radiation corresponding to the Lyman series. Now he can straightforward say first orbit, but he will say Lyman series because he wants you to know that everything to be remembered, right? So nth orbit to directly 1, right? Consider H to be the Planck's constant and epsilon naught is permittivity of the free space. The correct statement is or R. Okay. Multiple correct is there. Now if you see first option, he is giving magnitude of change in kinetic energy of electron can be expressed as, so H by 4 pi and N into Vn by Rn. See, here I am not answering the question, here I am explaining that how we will think on this question. Okay. So the problem is kinetic energy he is asking. Okay. So if a simple formula of kinetic energy, if I write down, see he have the velocity divided by radius. Okay. So if I write down just the formula of kinetic energy, right? Kinetic energy I have half mv square. Okay. Now the problem is he is answering in terms of h by 4 pi. If I see h by 4 pi, then I can see this only, that your mvr is equals to nh by 2 pi. Okay. This is only the I'm able to think to relate it. Okay. And that's what he want. Okay. So this if you put here, what he want, if you put the 1 m into v, 1 v you keep, okay, r will come and divide, and that's what your answer will match here. See, half 1 v you keep here and 1 mv if you put r you divide, so nh by 2 pi r. Okay, here what are the constants which will not change? So h is out and 4 pi, h upon 4 pi out, and you will have v by nv by r, right? And that's what he is saying. Kinetic energy difference, if you see, nv by r. So h by 4 pi, if you will subtract both the kinetic energies, that will be nv by r, nv by r. Let me write down for you. Okay. For the first orbit, kinetic energy for nth orbit, if you will write down nth orbit, so you will say h upon 4 pi into n times of vn by rn. Okay. And kinetic energy for first orbit, if you will write down, then you will say h by 4 pi into n times of v1 by r1. Okay, subtract both of them. Mod he is keeping to keep the value positive. Okay, he don't want us to confuse in that thing. Okay, just change he is asking, magnitude he is asking, so he is giving the mod, right? So A option is the correct answer, right? Now on the basis of A, we can directly go to the D and we can answer that. How? Magnitude of change in total energy of electron can be expressed as. Now if you know, total energy and kinetic energy and potential energy have a relation, right? So we said that the total energy, right, is nothing but negative of kinetic energy. Yes or no? Correct na? So this we say. How we say? You know that thing. Okay, I don't have to tell that thing. Many times it is there in the notes. We are not solving some notes question, we are solving JEE question. So I hope you have the basic idea of notes, obviously. So if we see that, then there should be just a negative value difference. Okay, and as he is asking magnitude, so their negative difference should also be not there. Okay, but here if you see, the answer is h upon 2 pi instead of h upon 4 pi. If there have been h upon 4 pi, I have ticked the D option also, but currently it got wrong. Okay, now B option and C option. See the B option. Magnitude of change in de Broglie wavelength of an electron can be expressed as, and C option is frequency of radiation emitted can be expressed as. Frequency of radiation. If you know frequency, how we can go in the frequency part? E square by 8 pi epsilon naught h. If you see, he is going in E square. E square, how can I go in the E square? How can I go in the E square? So if you think, there was somewhat, I can say, one only the formula there where it goes in the E square. Okay, if you write down K Q1 Q2 by R, okay, that's what your potential energy is, correct na? Okay, and kinetic is, this is potential energy in negative, right? And kinetic energy, this much, half of this comes. How it comes? Kinetic energy, you write down the attractive force between them, K Q1 Q2 by R square, right, is equals to centripetal force mv square by r, right? So this r cancel out, okay, and half you multiply both side, okay, and that's what the kinetic energy is, and the potential energy is this. So total energy that comes, okay, total energy what comes? Total energy is this half k e square by 2r, okay. This is the total energy with a negative, okay. So I'm just writing the magnitude currently, okay. Now this kinetic energy, total energy is equals to h mu, okay. This is equals to h mu, correct. So now from here, that's it, k value put, and I think in terms of r only is answer, yes. So we got this. So mu is how much? So frequency how much? This comes, k is 1 upon 4 pi epsilon naught, and 4 to the 8, and this will be e square by 8 pi epsilon naught into r into h, right? And for both of them, when you will subtract, the r will be different. Other than that, everything is a constant, right? So 1 by rn minus 1 by r1, right? So that's a 1 by r1 minus a 1 by rn. So this is option is correct. Okay. Okay, fine. B option remaining. So B option also have E square. Fine. Magnitude of change in de Broglie wavelength. Okay. Of the electron can be expressed as de Broglie wavelength lambda. Lambda. How we can go in lambda? Okay. So for that, if we see here, somewhere here, if we see total energy 2 pi r. So if you see here, total energy, okay. In total energy expression only, frequency is given. Kinetic energy, right? Kinetic energy terms he is writing. Okay, fine. Yeah, I thought in this thing only writing. So if we see here how we are created this thing also. So kinetic energy is how much? K e square by 2r. Okay, 2r. That's what I was thinking, that where is the problem? 2r. Okay. K is 1 upon 4 pi epsilon naught, 4 to the 8, right? So this will come k e square by 8 pi epsilon naught, okay, into r, right? R, right? Now if you see here, kinetic energy we want, right? So what you do is take the 2 pi r factor and take it this side, k divided, right? So what we did here is that we said that 2 pi r this side is equals to e square by k, you take in divide, okay. So 2 pi r, so 2 taken 4, so 4 pi epsilon naught, sorry, 4 epsilon naught remaining, divide k, 4 epsilon naught, 4 epsilon naught and k, this is what, right? Otherwise 8 pi epsilon naught, 8 pi r, yes, okay. So this 2 pi r is only equals to n lambda, yes or no, right? So that's it. So from here lambda came, e square by 4 epsilon naught into nk, right? N times of kinetic energy. Now if you will see the options, right? So here somewhat it looks like it is matching, but it is not, okay. If we have an n here, then it will match because n times of is there. So for k, for nth you will write down, then n will come. So this option gets wrong. Got it? So I was getting little bit trouble in this thing, okay, that what was the option. So if you see here, he is asking in terms of kinetic energy, right? So that is very important. In what terms he is asking? In that terms, what are the formulas given, right? He wants the e square also here, right? And he wants the radius also. Here he wants the e square and he wants the kinetic energy, right? So you have to relate all the formulas, and then we have to answer these questions. Let's see the next. Okay, next question is from projectile motion, and this was the question, you can say one of the easiest question possible in the whole paper. A particle is thrown with a speed v from a point O, okay, from this point he is throwing at an angle theta with the horizontal plane such that it passes through the point P at a height h of 1 meter and horizontal distance 5. So you can say this point is 5, 1. from O as shown in the figure. If acceleration due to gravity is g, then the correct statement is, okay, in terms of g only we have to answer. G value we will not put, right? As per the option we are able to see, g value we don't have to put. Got it? If you see 5,1, it is passing through, okay? Don't get confused, okay? We have y is equals to x tan theta into 1 minus x by r. This I told you to remember, correct na? Where capital R is what? Capital R is the range, right? So if you want, we need, I think, we have to put the theta and we have to get the v, correct? Where x and y are given, right? So x and y is at least fixed, right? So we can put the value of r here, okay? So if you put y is equals to x tan theta, okay, minus here what will come? Range value we know. Range is what? 2u square sine theta cos theta by g, right? U square sine theta by g, right? So here g will go in numerator, so x square g divided by sine cancel out, and this will be your 2 cos square theta, okay? I think that will be, anything else, u square. Got it? Because I prefer to remember this thing, okay? I don't go in this one. Okay, so this was the, now go to the option. He said theta 45, then v will be this value, right? So first of all, x and y are constant given. So x and y are what given? This is given 5,1, right? So this is given as 5,1 point. Okay, so put the value of 5,1. So y is 1 is equals to 5 tan theta. So tan theta is also given. I think for this part theta given. A part, let's solve by part by part. So A part we are solving. So A part he is saying theta 45. Theta 45. So y is 1 is equals to 5 into 1 minus x square. So x square, x is given as 5. 5 square into g divided by 2 cos 45. So that's a 1 by root 2. So that's a 1 by 2 into u square, right? So this quantity, this side 5 minus 1, 4. So this is 25g by u square is equals to 4. So u is what? 5 by 2 into root g. Okay. Is it 5 by 2 root g? A option, okay. Right. Second option, if theta equal to 45 degree, the particle reaches its maximum height before it reaches P. Okay. If theta is given 45 degree, then the particle reaches its maximum height before it reaches P. Now in solving this thing, what you do is that you go for the range. Why I am saying is this, that if particle is projected from here and it hits like this, right? If P is here, then the 5 will be more than r by 2, right? Because maximum height will be reached at a r by 2 range, right now? Range is r, so at r by 2 he will reach the maximum height. If your 5 is more than r by 2, then that's a after, it is passing through P after reaching the maximum height. And if P point is here, then 5 will be smaller than r by 2, correct? So why I am solving for r? Because r I have, right? Because I will use directly this formula, right? Y and x I have, so I will put the value, and r I will bring in terms of tan theta. You can bring either, or just first solve simply, easily. Why I should complicate? Y value 1 is equals to 5 tan theta into 1 minus x is 5 by r, right? So if you solve here, what are the given? B and C option both can be checked. Okay, 45 degree. If you will put 45, right? So B option, if I put 45 degree, theta equal to 45, right? So that's a 1 by 5 is equals to 1 minus 5 by r, right? So here 5 by r is equals to 1 minus 4 by 5. So that's a r is equals to 25 by 4, right? 25 by 4. So r by 2 how much? R by 2 is 25 by 8. So 25 by 8 is approximately 3, right? So 3 means what? What is happening? 3. R by 2 is 3, means somewhat like this may be happening, right? So what he is saying is, if theta is 45, the particle reaches its maximum height before it reaches P. Yes. So B option is also correct. Okay. So that's what happening. Because this is 25 by 8. Okay. Which is smaller than 5. That's why. Now, next C option can be also checked, theta equal to 30 degree. So if theta equal to 30 degree, if I put here 30 degree, I can rough it, right? I think you will not need it. Let me solve here only. Okay, see, theta equal to 30 degree. So if you put theta 30 degree in C option, according to C option, so 1 is equals to 5 into tan 30, 1 by root 3. Okay, 1 minus 5 by r. Okay, and this is root 3 by 5 is equals to 1 minus 5 by r. Okay, little bit difficult calculation. So 5 by r is equals to 1 minus root 3 by 5. That's a 5 minus, sorry, 5 minus root 3 by 5. Okay, and then r this side, this all quantity this side. So r will be what? 25 by 5 minus root 3. Okay, so 25, and here how much is this? So 5 minus root 3, 1.7, right? 1.7, 2 you consider 2. So 5 minus 2 is 3. 3, and this will be 8. And 8, if you do half, that will go less, right? And bigger number. Okay, r by 2, if you solve, okay, exactly you can solve if you get confused. 25 by 2 into 5 minus root 3. Okay, 5 minus root 3 will be a 3.7, right? 1.7, no, 3.3, and this will be 6.6. So that is a 6.6. 5, it comes, bigger number is there, that means smaller. So r by 2 is less than 5, r by 2 is less than 5 again. So this will be again, the particle reaches its maximum height after reaching P. No, so this will be not the option. Okay, then D option, if theta equals to tan inverse 1 by 5, the V is 125 by 125 root G. So tan theta put 1 by 5 and V you get. So that's a similar to A option, right? What we have to solve. So similar to A option, we can solve here. Y is equals to x tan theta minus x square G by 2u square cos square theta, where tan theta equal to 1 by 5. Okay, so y is 1 is equals to 5 tan theta, that's a 1 by 5, minus x square G by 2u square cos square theta. If you see here, 1 cancel out and this whole quantity came equal to 0. Means you have to be not defined. You have to be infinity. Okay, that means this option is wrong. Okay, so this option is also wrong. So I hope so this will be clear, right? Okay, clear. Now see. Next we have, okay, this question, see, from thermo. A quasi-static cyclic of a monoatomic ideal gas contains an isothermal process AB. So AB is an isothermal process followed by an isochoric process BC, okay, and an adiabatic process CA, C2A adiabatic. The volume of the gas are V1 and V2 at A and B, okay, respectively. If the cycle has heat input of Q in and output of Q out, then the efficiency of the cycle is defined as this. Yes, we know. Okay, the correct statement is, okay, if you see here, if you see A, C, D, all three options are in terms of V1 and V2, right? V1 by V2 or V2 by V1 is given, and on the basis of that, things are asked, right? So I would recommend that first you solve that only, okay? Let's say at A point, he gave us the volume as V1, right? Okay, so pressure, volume and temperature. Okay, so we will say pressure is P1, volume is as per given V1, and temperature is T1. Okay, I will write down for A, B, C, all of them. How I am solving, just try to understand. Okay, here volume is V2, temperature we don't know, and the pressure we don't know, right? And for C point, if you see here, what is the A to B is what? For the process I will use later. Now you use the process, okay? So for A to B, if he is using isothermal means temperature not changing. So temperature T1, okay? Correct. Second thing, here to here he is going by isothermal, correct na? So temperature same, so means P into V constant, right? So I can say here, let's say P2 will be there, but I am just solving. P1 V1 is equals to P2 V2. So P2 came how much? P2 came here P1 V1 by V2, right? So this is nothing, just I am eliminating the number of variables, P1 V1 by V2. Okay, I don't want to be calculation lengthy, I am just writing here only and I am able to answer from here only everything. Okay, so that all three variable came. Just we are writing in terms of what he gave V1, V2. Okay. Third term, he said B2C is what? B2C. B2C is an isochoric process. Isochoric means volume same. Volume same means volume same. That's it. Okay. Pressure can change. Temperature can change. Okay, fine. But there will be one relation, right? That pressure and temperature will be proportional. But let's see how to deal with that. Okay. If cycle has a heat. Okay. One more thing. C2A is adiabatic. So let's use that also. Right. So we can say volume we know. V1, V2. Pressure we know. So pressure we can get PV raised to power gamma. Correct? Na? So by that relation, if we go, then P1, V1 raised to power gamma is equals to P3 and V2 raised to power gamma. I'm writing between C point and A point. Right? So gamma is how much? Gamma is how much? F plus 2 by F. Right? Which gas he gave? Monoatomic 3. So this is 5 by 3. Right? 5 by 3. Okay. So 5 by 3 is there. So P3 is how much? P1 into V1 by V2. Okay. Into power gamma. Gamma is 5 by 3. 5 by 3. Okay. That's your P3. I can put the value. Let's put the value. Why should I keep there? So this is P1 into V1 by V2 to the power 5 by 3 comma V2 and temperature, right? Temperature also I think you can write down now, right? How you can write down temperature? Go by the isochoric, right? So volume is same, so pressure is proportional to temperature. So we can say P1 into V1 by V2 divided by here pressure is what? P1 into V1 by V2 to the power 5 by 3 is equals to T1 by T3, right? So T3 will come here, T1, T3 this side, and this P1 cancel out. This is power 1, this is 5 by 3. So 5 by 3 minus 1, this will be 2 by 3, correct? So this as it is multiply this side. So V1 by V2 to the power 2 by 3. Okay? So I hope that is clear. So that's a temperature. So that will be T1 into V1 by V2 to the power 2 by 3. That's your temperature. Okay. Now go to options. See. If V2 by V1 equal to 8, so V2 by V1 is 8. The heat released in the process BC is smaller than the heat absorbed in the process AB. So heat he is talking about, correct? So heat, now how you will write down the heat? A BC process, right? So BC process. Okay. So Q in the process of BC, right? How much it will be? What is the process? The BC process is here given isochoric, right? So isochoric heat is what? Q is equals to delta U plus W, right? But volume is not changing, so W0. So Q is equals to delta U. So that's an F by 2 NR delta T. Okay. That's a 3 by 2. And I think number of moles, how many given? Number of moles, monoatomic ideal gas container. Okay. Efficiency, eta. Okay. Just he is comparing only, so N only keep, right? So N, R and delta T. Temperature change, right? So temperature change is this minus this. Okay. So that's a V1 by V2 given, na? So V2 by V1 is given. So V1 by V2 is what? 1 by 8. 1 by 8. If you will put here, the final temperature is what? 1 by 8, right? So 1 by 8. So 1 by 2, 1 by 2, 1 by 4. So T1 by 4. So T1 by 4 minus T1, right? Okay. Temperature constant. How? So this will be how much? Minus 4, 3 by 8 NR T1. Okay. And the Q of which process he is comparing with? Is comparing with the AB. AB process is isothermal. Isothermal Q is what? Q or what? Heat absorbed in the process. Heat release and heat absorbed, right? So Q of AB. AB, right? AB. So that's a work done. That will be what? nRT. That's a T1 only, right? nRT1 ln V2. Final. Final is V2 by V1. V2 by V1 is given 8, right? So that's an 8. Okay. Plus your delta U. Delta U is what? 0. Because what is that? Isothermal process. Okay. F by 2 NR delta T. Now delta T is not there, right? So how it will come? So here how you will compare this? 2 cube, 3 will go out. So 3 NR T1 ln2. ln2 value I think he gave. ln2 he said 0.7 you consider. So 0.7, this is 2.1. 2.1 nRT1, right? And that's a 3 by 8. 3 by 8 is smaller obviously because he's saying just to compare, the negative sign is coming because it is released. Okay. So process heat released is smaller. Heat released is smaller. Smaller, yes. Yes, heat released is smaller. Correct. Okay. So 3 by 8, that's why it is a smaller comparison to 2.1. For the given value of V2 by V1, eta does not depend on the temperature of the isothermal process. Okay. If you see here, eta is what? Q in by Q out divided by Q in, right? So if you see here, this thing, okay, which you wrote here, if you don't write down the Q in, right? Q in is the QAB, right? That's an nRT1 ln of V2 by V1, right? And Q out, this thing, okay, F by 2 nR delta T. Delta T is what? Delta T is change in temperature. That's this one, right? So final minus initial, initial minus final, that depends on positive or negative, what you want to consider. I want a positive answer, right? So volume is here, pressure decrease, volume increase, right? Leave that thing, let's write down the value only. Final is T1 into, what is there? V1 by V2 into power 2 by 3, I think. 2 by 3 minus T1. This is Q out, right? So what you will write down, efficiency is, what he said, efficiency is Q in by Q out, Q in by Q out minus Q out, that's your work done divided by Q in, right? Net work done divided by Q supplied, that's the efficiency. If you will write down the values, right, here T1 will come common, okay, and T1 from numerator and denominator cancel out. That means what he is saying is correct. For the given value of V2 and V1, if I give you the V2 and V1, eta does not depend on the temperature of the isothermal process. Yes, as per I am solving, right, it is coming dependent on the V1 and V2 only. And degree of freedom as per the monoatomic gas, 3 will come. Okay, so it is not depending on the T1. So that's why it is correct. If V2 by V1 is 8, then the temperature of the gas at A. Now, just if you see C and D option, we can solve directly from this what I wrote here is V2 by V1 is 8, then the temperature of gas at A. Gas at A is T1. Gas at A is 4 times the temperature of the gas at C. So gas at C will be what temperature? Temperature will be here V1 by V2. So that will be 1 by 2, 1 by 4. So this will be T1 by 4. Okay. So that's what he's saying. Then the temperature of gas at A is 4 times of temperature at C. That's the correct option. Okay. D option, V2 by V1 is 8. Then the pressure of the gas at A, pressure is P1, is 4 times the pressure at B. Pressure at B. So B will be what? V1 by V2, P1 by 8. Yes or no? Right? So not 4 times. So D option is wrong. Okay. So if you do this part, right? Okay. Many times this will be helpful, right? Here it was helpful very much. Okay. In many questions it will be helpful, right? So you can solve for this. If this kind of graph is given, it will be very, very much helpful, because here much options were like that only to solve by this. So that's why. I hope this was doable. Next. The electric field associated with an electromagnetic wave traveling in vacuum is given by E0 sine 3y plus 4z plus omega t, where omega is the angular frequency. All quantities are in SI unit. The correct statement about the wave is or are. The wave traveling in this direction. Okay, so wave, we can say this both sign are positive. So wave velocity is, I think, 3j cap plus 4k cap, right? If we make it unit vector divided by its magnitude 5, and obviously in negative direction. So A option is correct. Okay, you can see this is the vector. Okay, make it a unit vector, so divided by 5, and negative will come because this when we write down, remember, if you write down y is equals to, or E0, E is equals to E0 sine, like this, if you write down, remember, kx plus omega t, right? Like this, when you write down, what you say here? Okay, you say that the wave is traveling in negative x, right? Minus I cap. Similarly, here also, when the coefficient is positive, same sign, that means minus. Okay, so that's how the minus will come. The magnitude of the wave vector is magnitude of wave vector is 0.5. I think wave number will come, right? I think wave number is there. Let me check from the official paper. Wave vector or wave number or what is it? Okay, wave vector only, same thing. Okay. Wave vector, wave number. But I was just confirming it. Okay. Magnitude of wave vector is, so k we have to solve, right? So if you solve for k, so k magnitude, if you see that magnitude is 5, right? So I think not the 0.5, so this is not okay. The value of omega is 1.5 into 10 to the power 9. Omega value, how you will solve? C is given 3 into 10 to the power 8, right? K is 5. So we can say that omega k is given, right? So k is what? C is given and k is given, so that will be omega by c, right? So omega is what? K into c, right? So this will come how much? K is 5 into c is 3 into 10 to the power 8, right? So that's a 15 into 10 to the power 8. Okay, so that's a 1.5 into 10 to the power 9. So C option is okay, right? The magnetic field associated with this wave is given by, okay. So magnetic field we have to give. If you remember, we have told you one trick. JEE Main also there have been many questions like this, right? So if you see here, what we have is the magnetic field associated. Magnetic field is asking, so alphabetic order B, C, E, right? So B is equals to C cross E, right? Direction for direction, C cross E, right? This like this you write down BCE, BCE, right? So here B will come what? C cross E. C is in which direction? What is the direction of wave? If you remember, you have already answered, this is direction 3j cap plus 4k cap, okay, with a negative, right? And E is what direction? E is given here I cap, okay. So here we can answer this. For the direction, if you want just the direction only, then we can say this will be C cross E. So C is, direction of C is what? Minus of 3I cap, 3j cap plus 4k cap in the bracket, okay, cross E, that is I cap, right? So this will come J cross I, or you can say negative is there. So I cross J, that will be k cap, right? So 3k cap, and then k cross I, okay, k cross I will be your J, and then minus is there, so minus 4j cap, right? So 3k cap minus 4j cap, right? And E naught by C will be there, right? Here it is written 4j cap minus 3k cap, okay. So this will be the magnetic field direction, I think, okay. So I think D option is not okay. Okay, fine, that's it. Okay, so D option is not okay. Next, section 3 we came now in. So we have 4 questions numerical. Okay, so we have to go 2 decimal, I think. Yes, round off to 2 decimal places. So first question, a tank contains 2 immiscible liquids of density 6 rho and 2 rho. So one liquid is of 6 rho, one liquid is of 2 rho. So this is 6 rho and no, this is 2 rho obviously, and this is 6 rho. Fine. The higher density liquid is filled up to a length of L by 2 from the bottom and a thin rod of density rho. So the rod have a density rho, okay, length L is fully immersed and hinged at the bottom so that it can oscillate freely as shown in the figure. If the rod is slightly disturbed from its equilibrium position like this, okay, the time period of a small oscillation. This is kind of a question which is solved in the notes, okay, and we have to just solve for oscillation, right? So very easy question, see how, 2 rho and 6 rho, fine. See here, we will displace it little bit. So from its equilibrium, we displace the rod. I will show little bit more, okay, so that things are visible here. Now what is happening? On the center there will be a mg. Yes or no? Right? Here from in the bottom liquid, right? So there will be a center of buoyancy at the midpoint, right now? Center of buoyancy. What will be that buoyancy force? Buoyancy force will be, let's call it B1. Okay. And here on the center of buoyancy there will be a force B2. Okay. What is the value? And this is the hinge point. Okay. From here displaced angle theta. Got it? B1 how much? B1 what? Density of the fluid, that is 6 rho into volume. Volume will be what? You can say every single time you can say mass is equals to density into volume. Rho is the density, volume is what? Let's say V. Okay, you can write down V. Length and area of cross section terms you can write down if you want to, or just you can say that volume is divided for this question purpose. You can say volume is V, below part V by 2 and above part V by 2. Okay, simple. Or you can say L by 2 into area of cross section. If you consider area of cross section A, let's say consider, right? So this will be area A into length L, right? This will be the mass. Okay. So volume is how much? Here area A into L by 2. Okay. Or just same in terms of that. Okay. A into L by 2 into G. This will be the buoyancy. I'm writing in terms of that mass M. If you see here, rho AL is replaced with M. Rho AL replaced with M, so this will come 3 mg. Okay, and B2 is how much? 2 rho. I think 2 rho only, right? 2 rho. This is 2 rho and same AL by 2, that's a volume into G, right? So this will be rho AL M, so this is nothing but mg, correct? Now, don't deal with forces, we have to write down the torque. Torque about this hinge point if you write down, the torque of mg will come in this sense and B1 and B2 torque will come this sense. And obviously B1, B2 torque will dominate and they will take it this side, right? So that's what restoring torque is, right? So if you write down B1 torque, this is theta, this is how much? L by 4, and this is for the B2 will be what? 3L by 4, and this is at L by 2, right? So this will L by 4 sine theta component will come. So here we can say that B1 L by 2 sine theta, L by 4, sorry. L by 4 sine theta, okay, plus B2 3L by 4 sine theta minus mg L by 2 sine theta. This is the net torque. Okay, torque equals to I alpha, moment of inertia, you can say M L square by, about this hinge point you can say ML square by 3 into alpha is equals to B1 value. If we see, then that's a 3 mg, right? So this will be 3 mgl by 4 sine theta is theta, okay, plus B2, that's a mg. So this is 3 mgl by 4 into theta minus mgl theta by 2, right? So that's a 3 by 4 plus 3 by 4, that's a 3 by 2, 3 by 2 minus 1 by 2, that's a 1, right? Okay. So here ml square alpha by 3 is equals to 3 by 2 minus 1 by 2, that's a 1. So this is mgl theta, right? So ml cancel out, okay, and time period he asked, right? So first to get the alpha will come how much? Here you can say 3g by L into theta, so that's an omega square. Omega square means time period is what? 2 pi by omega, that's a under root of L by 3g, right? What he asked? L by 3g. So 2 pi, we are getting the answer 2 pi under root L by 3g, right? And he's saying compared to 2 pi by n into under root of L by g. So if you compare, the n will come root 3. Root 3 means 1.73. 2 also coming, but 2 will not answer. We will answer till 2 decimals only, round off. So that your answer is root 3, 1.732. 1.73. That's your answer. Okay. So I hope 9th question is clear. Okay. Easy only. This was doable question. Okay. So if you see fluid mechanics also asked. Now we have Carnot engine. Okay. Shown in the figure 5 Carnot engines, each of efficiency eta. So each Carnot engine is efficiency eta, and same number of cycles per unit time are operating between 6 heat reservoirs the amount of heat released per cycle by one engine is completely absorbed by the next engine. So what he is giving, that he is absorbing. Okay. Consider Q0 to be the amount of heat absorbed per cycle by the first engine, and W is the total amount of work done by the engine per cycle. Then the net efficiency of the system eta net is W by Q0. Okay, fine. Total work done W1, W2, W3 till W5 is what? W. Okay. So efficiency eta net that is given to us is W by Q0. Okay. Now what is released? We can say Q5. Okay. So can we say this thing that Q0 is given? Okay. And what is released? W plus Q5. Okay. This relation is valid. I think you will understand this is valid. Okay. This value is given to us. We have to answer the eta, efficiency of each engine, right? If you write down here between any giving input, Q in, and there is a Q out, and there is a W, right? If you will see the relation, you will always say Q in is getting divided, there is a work done, and there is a Q out. Okay. So you can always say that Q out will be what? Okay. Or not this way. Let me give you this thing. Let's write down in terms of efficiency, right? In terms of efficiency, if we see, okay, so you will say that efficiency is Q, the work done, right? That's a Q in minus Q out. Okay, divided by Q in, correct? So from here, if you divide 1 minus Q out by Q in, right? So take this quantity this side, eta that side, 1 minus eta. So Q out will be Q in into 1 minus eta. Agree this thing, right? So if I write down this thing for the first one, then I will say what? That Q out, that's a Q1 is equals to Q0 into 1 minus eta. Okay. Similarly, we will write down Q2, right? Q2, what you will say? Q2 you will say Q1 into 1 minus eta. Correct na? His efficiency, and his efficiency is also eta, right? And Q1 value is what? Q0 into 1 minus eta, so 1 minus eta square will be there, right? Similarly, Q3 you will say Q2 into 1 minus eta. So the Q2 is what? This. So that will come Q0 into 1 minus eta to the power 3. Similarly, Q5 at the final, that will come Q0. This is going Q0 only, 1 minus eta to the power 5. Okay. Like that it will come. Q4 I didn't wrote middle. So Q5 I bring in terms of Q0. That's what I wanted here. Okay. So that's it. My final answer is from here only. So Q0 is equals to work done plus Q5. Q5 is what? Q0 into 1 minus eta to the power 5. Okay. So now what you do is that work done by Q0 is given. Okay. So what you do is Q0 divide everywhere. So you'll have 1 is equals to work done. That's a work done by Q0. That's a net efficiency, right? Eta net, which is given, plus 1 minus eta to the power 5. Okay. Eta net is given 211 by 243, right? So put it here. 1 is equals to 211 by 243 plus 1 minus eta to the power 5. Okay. So 1 minus eta to the power 5. Am I correct? Yes, I am correct. Is equals to this 243 minus, this will go this side and LCM. 243 minus 211, that will be your 32, right? Divided by 243. Okay. So if you will do here, this will be, I think, 2 to the power 5, right? 4 for the 16, 6, 2, right? So this will be 3 to the power 5. Okay. So 1 minus eta is equals to 2 by 3. So eta is equals to 1 minus 2 by 3. That's a 1 by 3. That's a 0.33. Okay. That's your final answer. Okay. I hope so this will be clear. Main thing was this thing. Okay. If you write down like this, it will come. Got it? So this question was easy, but if this got clicked, then only, right? Next we have 11th question. Okay. This is also, I think, thermo, they gave too much weightage. Okay. That should be given, right? because in the engineering part also you have thermodynamics very much weightage. Okay, there also heat and these all things comes. As shown in the figure, an insulated container is fitted with a thermally conducting but immovable partition. So P1 is a partition which is not moving, okay, but thermally conducting means heat can pass through it. And a freely movable but thermally insulated. So here heat can't pass, but it is movable, right? P2 piston. The partition P1 with thermal conductivity K. So his thermal conductivity is given how much? K. Okay. And cross section area A. So here cross section area how much given? A, through which heat can pass. Width X given. Width X given. Divides the container into two sections, S1 and S2. Yes, each containing 1 mole of gas. So here how much? 1 mole, N equal to 1, N equal to 1. Monoatomic means degree of freedom 3 if required. Okay. The piston P2 moves freely such that the gas in S2 is always at atmospheric pressure. So here as P2 is moving, keeping the pressure constant, atmospheric pressure, right? So here isobaric process. Which process is this? Isobaric. Okay. Fine. Initially the difference between the temperature of the S1 and S2 is delta T naught. Okay. The time it takes for the temperature difference to become delta T naught by 2 is okay. So initially there was a temperature difference due to which heat will flow, right? And finally the temperature difference is delta T naught by 2. Okay. Because the volume of this side portion, S1 portion is constant, so this we can say as isochoric. Okay, volume constant process. Correct. Okay. So here we can say that the heat given by this will be heat taken by this. Correct? Na? So here I can say the dq you will write down. Okay. Let's write down in next page only everything. Heat given. Okay. Through the isochoric process, so volume constant. So work done 0. Right. Work done 0 means everything is going through the delta U. So that will be F by 2 nR dt. Right. Let's call it nR dt1. Right. And heat given is there. So minus will come. Right. And similarly for that S2 thing, okay, dq will come how much? Same dq will be there because the heat given by this will be heat received by him, right? So dq here will be what? F by 2 plus F plus 2 by F, right? Na? So here I think monoatomic given, na? Directly write down 3 by 2 and 5 by 2 if monoatomic given, right? Monoatomic given. So here we can say, why to complicate? 3 by 2 and here what will come? 5 by 2 nR dt2 like this, right? Okay. And here n is also given 1, right? Now, so n is given 1, n is given 1. Fine. Now next what? Now what he said, heat given by this is heat taken by that. Okay. Second thing, we have the heat transfer chapter also applied on this cross section. So we can say here that dq by dt. Okay, time only is asking. Ka delta T by X, correct? Okay. Here first of all we have to deal with delta T only, right? So what you do is that you get the value of d of your delta T, right? So that will be your dt1 minus dt2. Okay. So dt1 minus dt2. So here it will be, this negative will come, right? So if you put here, okay, so d delta T, dt1 value if you put here, so let's solve, let me solve from here. So dt1 will be how much? 2 dq by 3r with a negative, okay, and here dt2 will be how much? 2 dq divided by 5r, right? If you put value here, what will come? T1 minus 2 dq by 3r minus dt2 will be what? 2 dq by 5r, right? So d of delta T will be what? LCM if you take 3 to the 15, this will be 10, 10 minus 10 plus 6, 16. So this will be minus 16 by 15r dq. Okay, this will be your thing. Okay, dt multiply this side. Okay, rest all things are given like that only, right? Cross section k is given k only, and A is given A, X is given X. That dq value put here, dt take this side, right? So with the negative, it will come how much dq? dq will come minus 15r by 16 into d of delta t is equals to ka by x delta t into dt. Okay, dt I didn't keep this side because you can keep it. Okay, your wish. Now if you see all this constant, you take that side, delta t you bring this side, and with respect to delta t only we have to do the integration. Okay, why? Because delta t is changing from how much? I think here from delta t naught it is changing to delta t naught by 2 in how much time? 0 to t. Let's say. So here integration limits, as I told you just now, minus you keep here, you will need here minus delta t by delta t, okay, is equal to rest all constant that side. So 16 ka by x, 15 rx, okay, 15 rx and delta t the dt. That's it. 16 ka 15 rx. Yes. Okay. Here integration from where to where? Here 0 to t, and here delta t naught to delta t naught by 2. Okay. Dx by x, that's integration is what? ln x. Correct na? So go by that. Okay. So what we can say? ln of delta t, right? Limit from where to where? Delta t naught to delta t naught by 2 is equals to minus is there. Remaining thing 16 ka by 15 rx. 16 ka by 15 rx into, this is small t. Correct? Yes. So this will come ln 2. Okay, ln 1 by 2 will come, minus is there, ln 2, right? So ln 2 value I think given, ln 2 he said take 0.7, right? 0.7, so this is 0.7 is equals to, and this quantity is now take this side. And that will be your final answer. So you can say 0.7 into 15 Rx divided by 16 Ka is equals to T. This is what we wanted. Okay. Now if you compare with the value given NXR divided by Ka, XR Rx. Okay. So this is your N. 0.7 into 15 by 16. Okay. Numerically solve, like by calculator you solve, and then after put it to two decimals, up to 2 decimal you can round off. Got it? Okay. So I think doable or not? Doable? 16 minus 1 if you write down, it is doable. 16 minus 1.7, do like this. Okay. If you don't have the calculator, you can do like this. 16 minus 1, you will write down 1 minus 1 by 16. Okay. So this is 0.7 into 16. If you will go 1 by 16, right? Multiply with the factor and do it. Okay. Your headache, that is. Okay. I think doable now. So main part is this thing. Okay. This thing can look little bit harder. Okay. How this thing we wrote. Okay. And the mistake of the sign. If you make a sign mistake also, calculation will go wrong. And even if someone gets this kind of answer, he also thinks that they're getting somewhere wrong, right? But it's okay. JEE Advanced can ask this much calculation. That's not a problem. Next. Okay, this one more. Here, question number 12. A hollow right circular cone of base radius r and height h. Okay. Base radius r and height h with its tip at origin, rotating about z-axis. Z-axis like this rotating with angular velocity omega. So angular velocity omega, radius r, base height h shown in the figure. The cone carries a total charge q uniformly distributed on its curved surface. On the curved surface only, charge is distributed how much? Capital Q. The magnitude of magnetic field at the point 0, 0, z. So means on this, okay, at somewhere very much up, okay, where z is very large comparison to r and z is very large comparison to h is this value, okay, n mu naught by 4 pi into q r square omega by z cube. The value of n is. Now solving this question is automatically a headache. Okay, some people can think that sir, we can do like this from sometime very much you can say wrong you can do in this. Let's say this is the cone. You will consider a ring here, sir. Okay, on which you will consider the charge. And from here at a z distance away, we will consider this ring. So this angle will come alpha. Okay, for all the rings, this angle is theta is constant, right? And for every ring, we know how much is the magnetic field there, right? So we can write down in that manner. But that calculation, if you will sit and do, it will go very, very lengthy, okay? But there is a method. What method? When he said here that Z is very large comparison to R, means he is very much away. Z is somewhere here. Point is somewhere here, right? So you can consider this cone, okay, and calculate its magnetic moment and consider it like a dipole. That's it, okay? So the main purpose is to calculate magnetic moment, okay? Similar kind of question have came last year, okay? Where we have to solve the magnetic moment, and how we will solve, if you remember, we will solve like this. Magnetic moment divided by L is equals to Q by 2 times of mass. Okay, this was the formula used. We are not calculating vector, okay? We are just calculating the magnitude, okay? How it is rotating, depending on that direction will be decided, right? With what angular velocity. So magnetic moment vector I'm mentioning just now, okay, because MM will, you can say same it can look, or just don't write down it as a vector and write down it as like mass, okay, or a small m, your wish, okay. Now here capital M divided by angular momentum. Angular momentum, how we write down? I omega, right? Now remember how to consider the I. Last time it was more harder, okay? Last time it was a solid sphere and hollow sphere question kind of that, okay? There was a sphere which was conducting solid sphere. Conducting means charge is on the surface, right? Charge is on the surface means you have to consider the moment of inertia according to the hollow, right? I know it's a solid, right? But these calculations are done on the basis of according to the charge distribution, right? So here charge distribution is on the curved surface, right? Curved surface. So here how much is the moment of inertia of cone about this axis? Can you tell, right? We can directly compress it like this, because if maybe it can confuse you, but if you know the moment of inertia calculation very much, then you can solve it. I know mass is here, right? Okay, on the surface. If this is the axis, the condition is this much only, that I should not bring any mass particle closer to the axis and take away from the axis, right? So if I displace this mass here only, right? Correct now? Then I am not making the disk as non-uniform also, okay, because this is angle like this only, and I am not bringing any mass closer and making it away. So moment of inertia will not change and it will make a disk. If it is making a disk, moment of inertia is mr square by 2, right? So that's a mass. So how much will come? Small m r square by 2 into omega. I omega is equals to charge is capital Q divided by 2 into small m mass, right? So mm cancel out and this will multiply that side. Magnetic moment came how much? You can say by 4 will come. Mm cancel out. So Q r square, okay, omega by 4. Agree? Yes or no? Yes. Okay. So that's a magnetic moment. Okay. Now what is this point? I can say he is rotating this way. Okay. Magnetic moment is this side. So we can say magnetic moment direction is this. So this point is lying on the axial position, right? So axial position magnetic field is what? You can say 2k, that is mu naught by 4 pi. Okay. 2k m by z cube, right? That's the z r cube, right now. So here if you put the value, that's a 2 mu naught and his numerator is q r square omega and all denominator 4 pi z cube into 4, right? So this will be 4 to 8, right? Let's compare with the what he is giving. 4 pi he said keep. Okay, so if we keep and we compare, so then n is 2 to 1 2 will cancel out and 1 2 will be remaining. So n is 1 by 2. 1 by 2, sorry. N is how much? 1 by 2. Okay. Got it? So that n will be 1 by 2. That's it. Okay. I remember, like we remember for the electric dipole. Okay, that way only 2k p by r cube. Okay, so k we replace with mu naught upon 4 pi. If you remember in notes, I have compared that, and then that's how I solved, right? So you will able to do, I think. Okay, this was doable if you click this thing. Okay, and after clicking also correctly doing it, because last time a question came, so you should have done this question. Okay, if you have done the previous year JEE Advanced question only, right? Many times it have asked, not just previous year. Section 4, we have multiple choice question. Is it? We came? Okay, fine. Okay, section 4. So we are in multiple correct now. Okay, let's see. So we have list 1 shows the configurations made on the straight and semicircular narrow tubes containing air. Okay, so here we will go with the optional elimination, okay, as fast as possible. Okay, see here first. Sound wave of wavelength lambda given 0.29 meter enters this structure at point S. So it enters at point S. Let's take P. Okay, and sound detector is D is the placed here. Okay, between point S and D the sound travels only through the tubes. Okay, only through the tubes. Maybe the 2 tubes are there. List 2 contains the possible smallest value of L. Smallest value of L, not the L. Smallest value of L, for which the detector D records maximum amplitude. Ignore effects of sharp corners. Okay. Now let's see. Here one sound will go straight L and one sound will go through pi L by 2, by 0.5 into L, pi R, right? So we can say the path difference, for the maximum amplitude we know path difference should be N lambda, right? So path difference is 0.5 L into your R, pi R, okay, minus L. This is the path difference, pi R minus L, right? This is L, this is pi R, correct? Is equals to N lambda. Now for maxima, for the minimum L, the minimum N should be there, that will be 1. So N equal to 1 we will put, and from here L will come how much? Lambda, that's a 0.29 divided by, this is pi by 2 minus 1. Okay, pi by 2 minus 1. If we will solve this, pi by 2 is 3.14 by 2, that's a 1.57 minus 1. So that's a 0.29 divided by 0.57, right? 0.29 by 0.57. If you will solve this, 0.3, 0.6, this will come half only approximately, so 0.51. Okay, this is 0.3 approximately, this is 0.6 approximately. Okay, you can say that's a 0.5, right? So that's the third option. So P will match with 3. If P match with 3 at the same point, you know A and B is not the answer, correct? So confusion is only remaining is now C and D. Now I can solve all of them, right? But why should I, right? If I am in exam, I will not solve for Q. Why? Because Q is not helping me to eliminate the option, and S is also not helping me. So I will go with the R, right? So if I go with the R, right? R I will say here L directly, and here L plus this pi R. If this is L, this is L. So this is diameter is how much? Root 2L, right? So radius will be what? Root 2L by 2. So here you can write down 1 is going L plus pi into R. R is what? Root 2L by 2, right? Minus L, right? This is the path difference. This is L plus pi R, okay? Where R is this, diameter by 2, minus L, this side path, right? This should be equal to N lambda, that's a lambda, okay? And L will come how much from here? If you see here, L is by root 2, so lambda root 2 by pi, okay? Lambda is 0.29 into root 2 divided by pi. So this is now calculative answer is there. Okay. So that's a 0.29 multiplied by root 2, that's a 1.414 divided by pi, 3.14, 0.13. 0.13, that's the fifth option, right? So fifth option, R fifth means D option, okay. Okay, so R will match with fifth, and that's it. Okay, little bit calculation is there. You have to calculate 3.14, 1.41. Okay, you put it and try to solve it. Okay, you will match it. Okay, don't worry, easily. R1 is there or 5 is there. 1.32 is there, and here 0.13 is there. If you just multiply this 0.29 and root 2, okay, and you will able to answer that who is bigger, numerator or denominator. You will find out that denominator is bigger. 3.14 is bigger. Why? Very easily came. If you see here, I have to get 1 or 5th, right? Exact calculation also I don't need here. See, 0.29 into this is 1.4, right? 14 and 3.14, right? 1.41 is there, multiply with a number which is smaller than 1, right? So this will go smaller than 1.4 for sure, right? Smaller than 1.4, and here what? 1.3, correct? And then divided by 3 is there, correct? Means very small number will go, obviously it will not come nearby 1.3, right? It will go very small, so obviously fifth option, right? So R will match with fifth, D option answer, and move to the next question. That's it, okay? This question is a theoretical question which came from, you can say, NCERT, okay? But if you have focused little bit in the class, in the theoretical, like when the teacher explains that time, right? So you can answer without the NCERT also, okay? How? Little bit confusion can be there, but still. See, for the S, dark and bright fringes, we know diffraction happens, right? Dispersion, reflection, total internal reflection, this doesn't happen, diffraction. So S is 3. If S is 3, that means D option gone, okay? Now try to focus. I can match 2 or 3 of them, and then after I can say that answer came. But let's say I don't know much of these things, right? Then what will happen, right? Now partially polarized sunlight, okay? First of all, in rainbow question, R, what can be possible, right? People can think, if I have shown in the class 1 video, right? In that I have shown that through there is a, you can say, water molecule through which light comes, dispersion happens, then reflection happens, okay, it comes back, and then dispersion again happens. So there is a reflection part also, but just wait for it, okay? So you can say that, sir, there is a total internal reflection also, there is a dispersion also, there is a reflection also, okay? You call it reflection, but dispersion is for sure there, right? Rainbow dispersion is for sure there, right? So either 1 is there, sir, or 2 is there, correct? So either in R 1 is there or R 2 is there, correct? So either this 1 or 2, anything is possible. So B, R is not eliminating, okay? But as we know, dispersion is there. Obviously without dispersion, not possible rainbow formation. So R we can say 1, and easily I can say that the C option is eliminated, okay? But just wait. Partially polarized sunlight, okay? Now polarization, if you remember, okay, we can't say dispersion or reflection or total internal reflection. Why? Because when we taught you Polaroids, okay, I'm not answering by NCERT, I can match directly, okay? But how I'm answering is that I'm saying that when we taught you Polaroids, we said in that there are organic, there are molecules, right? Okay, which are carbon chains are there, which are arranged in such a manner, okay, that if you align, then that component will be absorbed. Okay, sorry, perpendicular component will be absorbed, and along that it will pass. Something like that was there. So there is a molecule, correct? So what do you think? Molecules are there, the chain is there, carbon chain is there, or something chain is there of the molecules, right? So that is what scattering will happen of light by molecules in the atmosphere. So this partially polarized sunlight will come from fourth option. Okay, scattering of light by molecules in atmosphere. So Q will match with 4. If Q match with 4, you have A option. Okay, and as I was saying, if you Q match with 4, then R will match R as per matching with 1, and that's what I was saying, that R is 1. Okay, and the P option, that is matching with 5, you can say directly also, or if you how it happens, let me explain you. Colorful sky in North Polar region. So if you have seen some YouTube video kind of things, you have seen there, okay, in social media it is too much now, okay, green color kind of thing comes there, right? Okay, recently one Hello World picture also came of that. If you are not, because you are continuously studying, you are not aware of this, it's okay. But colorful sky in the North Polar region, okay, if you read the fifth option, emission of radiation from oxygen and nitrogen atoms excited by the charged particles, okay. If there is a colorful sky, right, okay, there is a high chances, if you are able to tick here, you will able to satisfy yourself that P is matching with fifth, okay. How? Excited state is there, from excited state it will come to ground state, that time it will release, that way you can satisfy your, but what happens is that on the North Pole, there is a magnetic field, right, so there are charged particles here, and they come with the sunlight contact, that time it happens, okay. In the magnetic field region, very high magnetic field region, when the charged particles come in contact with the sunlight, that time. Okay, as far as I know about these things. Next, this one more question is there, I think, and then this one more question is there. Okay, these both are very easy questions. Okay, now see, so P, Q, R, S options are there corresponding to list 2, 1, 2, 3, 4, 5 options are there. Okay, this is also same optional elimination we will do, but let's read the question what is there. List 1 contains 4 conducting loops lying in XY plane. As shown in the figure, the loops are rotating about Z axis, passing through point O. Okay, passing through point O. This point O passing through that, it is rotating like this. With time period capital T in clockwise direction like this. Okay, the region X greater than 0 contains a uniform magnetic field. This side uniform magnetic field out of the plane. Okay, list 2 contains qualitative variations of the induced current I with respect to T for each of these loops. Choosing the option which describes the correct matches with the entire entries in the list 1 to those list 2. Okay, this is very easy question. Last year one question came in what which we have told you that it is matching from one of H.C. Verma's questions. Okay, that was a disc hanging, right, and then it was rotating like this, going like this. Okay, not one question was there in which it was going in half of the medium, there was a magnetic field, half of not there. So when it will go and rotate, there was a variation he asked, and in that question something like that graph only was given. Okay, if you will find out there, it will match, not the S.C. Verma one, other one. Okay, that was very good question. Now let's focus on this thing. This is very easy. See how. When this will rotate, right, let's say it is rotating with, he said here, time period with time period T, capital T, means omega is constant, time period is constant. If time period is given, okay, time period is not changing, means omega is constant, omega is equals to 2 pi by time period, right? So time period have a certain value, so it is rotating with a certain time period. Okay, now when it will rotate, you can say that when this rod will go here, right, there is an area here, right? Okay, so you can write down the flux. Okay, I will not write down. Why I will not write down? For this rod only, there will be a you can say it have a velocity, right? So it is moving like this. It will come here at this time, correct? When it will be here, at that time this portion of the rod is there. In this circular part there will be no EMF, right? Okay, but in this part there will be EMF, right? Sorry, in this rod part there will be EMF, on the circular part there will be no EMF, right? So in this EMF will be generated, so EMF will be there till it rotates here, right? And then it will come like this, correct? After that, this is out of the magnetic field and this is inside the magnetic field, right? So I can say that when one rotation completed, it will have, but if you see, initially this is the rod which is going in this direction. Okay, so magnetic field out of the plane, V cross B this side down, okay, this side, and when it will rotate and come back, the other part of the rod, okay, that time this we have this side, we will come that side, so magnetic field again this side, oh, sorry, EMF this side again, right? So one time positive, one time negative current. Okay, opposite, he will provide a current in this way, right, and that rod will provide a current this way, right? So exactly opposite of this, so you will have the option 3 here, right? So P will match with 3 for sure. Okay, because just half their EMF, half EMF will come, and then again in half rotation other EMF will come, right? But there will be a constant current. Why constant? Because omega is constant, so omega T, you can write down the flux. B into, I was avoiding that, but it's okay. Let's say it rotated theta, that theta is omega T. Okay, so pi r square into omega T divided by 2 pi, you can write down like this. Okay, area of the sector. Differentiate, that will give you the EMF. Differentiate, this is linear, right? Na? Time period constant, so omega T, you will write down the angle, right? So omega T, that's what, here will come what? Constant. EMF is constant. EMF constant means current is constant. Okay, current is constant means current can't come the time dependent. So fifth option will not match with anyone. If fifth option is not matching with any one, that means A option gone and D option gone. That way you can be little bit more faster. Okay, now as I match the P with 3, okay, so C and B both are coming. Okay, so let's see, Q you can't go, Q2 2, R1 and R5. Okay, so R can give you the answer, only R can give. Okay, so if you see the R, what is R? This one. Okay, See, if R is like this, as soon as the first part of the this is loop is like this 60 degree, okay, only 60 degree, correct? So this 60 degree is there. When first rod will enter the magnetic field, there will be a EMF, right? As soon as 60 degree completed, both are in the magnetic field, right? Like this, okay? At that time, here till here there is a magnetic field, right? As soon as this came, now both came, so this is providing a magnetic field. If you see, if rod is going this side, V is down, B is out. So V cross B will come like this, V down and B this side. So this side my EMF, right? So in this EMF will come down, okay, and in this one also EMF down, right? So current will flow in this one down, this one down. So both have the EMF this side, so this will cancel out and 0, right? So after passing this 60 degree came inside completely, then EMF 0. Until this is going like this here, till that EMF is 0 only. So there is a certain 60 degree angle till that EMF is there, then after 0, and then when it will start coming out here, you can say it is this part, okay, this is one hand, this is one, right? This is 60 degree angle here in between them. And when one came out and another one is coming out just now, till that time there will be a EMF, right? So option 1, got it? So R have the option 1, R have the option 1, C option, okay? R option 1 means C option. Got the point? Okay. So this way, if you will do, you will able to answer. I can match all of them if you want to, okay? If you see here, I will explain this one also. See, question doable, did already completed, but still if someone have not understood, okay, let's try to explain also a little bit more. When this part entered, see here we have 4 parts, 1, 2, 3, 4. One part out, okay, one part inside, right? So there is a EMF. All 3 are outside, so there is a net EMF. Net EMF means something will come, right? Then after, as soon as second will enter, then you have to see what is the shape. Shape is like this. This is not touching here. This is here like this. So this have a EMF this way and this have a EMF this way. So this will cancel out 0, okay? When third one will enter, then this will have a EMF this side. So when third one enter, there is a net EMF, right? When fourth one enter, when fourth one just enter, first one is out, okay? So this will match with Q. Q will match with 2. This will see. First one enter, there is a EMF. Second one, by the time this entered, now after this entering and before this enter, there is a 0. So these 2 enter 0, okay? And then after when third enter, there is again a EMF, right? And then again this will, when enter, this will go out, right? So if this came in and this went out, so this is not there. So again 3 but negative, right? And when again same thing will happen and second option will come, okay? Understood? I hope so this is clear, okay? Easy question is there. Remember the circular part will not give any EMF, right? Because both the points are at the same distance away. This is very basic thing. We have discussed this thing. If you remember, there is a proper derivation in the notes. If for a circular wire, right, rotating this in a one plane only, this is in a plane and rotating with omega, right? There is a formula written for this, for current flowing in that. Next, easiest question of this paper, one of the easiest. See, list 1 shows 4 plane structure made of uniform solid rods, okay, each of mass m and length L. Each rod is mass m, length L. In list 2 possible moment of inertia of this structure about axis OCO dash, which is in the plane, right, which lies in the plane, he mentioned here, okay. If you remember, notes question is there. Similarly, this L, right, so this will be L sine 45 and this will be also L sine 45, right? Both are m mass. So you can see total moment of inertia for P option. If you will see, P will eliminate some options. Don't know, we'll solve for. But if you want, you can go with such an option which is directly able to eliminate. Okay, I think everyone is same only. Just P have 3 of them have 5. So possibly 5 is only the answer. I don't know. So you say 2 times of one rod. One rod is what? M L sine 45 square this way, right? Perpendicular component we have in question in the notes. Square divided by ML square by 3 na? Yes or no? 3. Yes. So this will come cos sine 45 1 by root 2, 1 by root 2 square 1 by 2, 2 cancel out. This is ML square by 3. So ML square by 3 means 5th option. 5th option means P5 option means B option cancel out. Like that we have to do. Okay. Then after you can go with the Q, but I would recommend that if B option is eliminated, who is eliminating more options, right? If R we go, then it's a 4 2 2, Q 1 3 4. So Q can eliminate. Okay, Q can eliminate 1, 3, 4. Right, fast. Okay, Q if you solve, see L sine 45, sine 60 and L sine 60, and this whole mass is at a certain distance. How much? L sine 60. Okay, whole this M mass is at L sine 60 distance, right now. So moment of inertia, if you write down I is equals to, for these two rods, 2 times of ml square by 3, where m L square sine 60, sine square 60 by 3. Okay, these are two rods, plus whole mass is at L sine 60 distance, so m L sine 60 square, right? Correct. I ml sine 60 root 3 by 2, so that will be 3 by 4, 3 cancel out, 4 1 by 2 ml square. Okay, plus here L sine 60 3 by 4, so 3 by 4 ml square, right? So this is how much? 3 by 4 plus 1 by 2, 4 2 5 by 4 ml square, 5 by 4 ml square, any option? 5 by 4 1 Q1 A option. Okay, so I take the A option. Got it? So I think that's all done. Okay, I hope all the questions are answered properly. If you have any doubt, you can ask. Okay, we will clear all the doubts. Okay, and in this particular paper we don't have confusion except that one focal length question. Okay, so let's wait for JEE Advanced answer key, and then let's see if there is a change or he will consider this as the answer. Okay, thank you.